Download this code from codegive.com, link in the description below. OK, let's dive into the world of reactive programming on Android using rxjava. I'll provide a comprehensive tutorial with explanations, code examples, and best practices, drawing upon the concepts and approaches commonly used by developers like Ivan Morgillo, though I can't definitively say exactly what Ivan Morgillo would write. Android reactive programming with rxjava, a deep dive. 1. What is reactive programming? Reactive programming, RP, is a declarative programming paradigm concerned with data streams and the propagation of change. It's all about reacting to events as they occur. Key concepts. Data streams. Represent data that flows over time. Think of a stream of user clicks, sensor readings, or network responses. Observers. Consumers of the data streams. They react to data emitted by the stream. Operators. Functions that transform, filter, combine, and otherwise manipulate data streams. Schedulers. Control the threads where the stream emits and observes data. Benefits. Improved responsiveness. Reacting to changes immediately leads to a more responsive user experience. Simplified asynchronous operations. Handles background tasks, network requests, and UI updates with ease. Composability. Complex operations can be built from simpler, reusable components. Error handling. Robust and centralized error management. Improved code readability and maintainability. Clear declarative style. 2. rxjava, the reactive library for Java and Android. rxjava is a Java implementation of reactive extensions, Rx. It provides the core classes and operators needed for reactive programming. rxjava works perfectly with Kotlin and provides a great complement to coroutines. 3. Setting up rxjava in your Android project. Add dependencies to build. Gradle, module, app, sync project with Gradle files. After adding the dependencies, sync your project with the Gradle files. 4. Core rxjava concepts. Observable. Represents the source of data. It emits items, values, over time. There are variants of the observable suitable for specific use cases. Observable T, emits 0 or more items and may complete or error. The most general type. Flowable T, designed to handle back pressure, more on this later, especially for large streams of data. Single T, emits exactly one item or an error. Useful for single-shot operations like network requests. Maybe T, emits 0 or one item or an error. Completable, emits no items, only completion or an error. Useful for operations that only need to signal completion, example saving data to disk. Observer. Receives items emitted by the observable. It has methods to handle events. Unsubscribe, disposable D, called when the observer subscribes to the observable. Next, TT, called when the observable emits a new item. Error, throwable E, called when the observable encounters an error. Complete, called when the observable completes successfully. Disposable. Represents the subscription between the observable and the observer. It's important to dispose of subscriptions to prevent memory leaks. Schedulers. Determine the thread on which the observable emits items and the observer receives them. Schedulers.io, for I/O bound operations, example network requests, database access. *schedulers.computation, for CPU-bound operations, example calculations, sorting. *Android schedulers.main thread, for updating the UI on the main thread. *schedulers.new thread, creates a new thread for each operation. Use sparingly. *schedulers.single, executes tasks sequentially on a single thread. *schedulers.from, executor, create a scheduler from an executor. 5. Creating observables. rxjava provides several ways to create observables. *observable.just, item, emits a single item. *observable.from iterable, emits each item in an iterable. *observable.create, emitter, provides the most control over the emission process. *observable.interval, period, unit, emits a sequence of integers at a fixed interval. *observable.defer, supplier, creates an observable only when subscribed to, by calling the specified supplier. 6. Operators, transforming and filtering data streams. rxjava provides a rich set of operators to manipulate data streams. Here are some of the most commonly used operators. *map, function, transforms each item emitted by the observable using the provided function. *filter, predicate, emits only the items that satisfy the given predicate, a function that returns a boolean. *flat map, function, transforms each item emitted by the observable into another observable, and then flattens the emissions from these new observables into a single observable. Useful for making asynchronous calls for each item. *concat map, function, similar to flat map, but maintains the order of emissions. *switch map, function, similar to flat map, but when a new item is emitted, it cancels the previous observable if it's still running. Useful for search suggestions where you only want the results of the latest query. *debounce, time, unit, emits an item only if a specified time has passed without emitting another item. Useful for handling user input, example search boxes, to avoid sending too many requests. *distinct, emits only unique items. *take, count, emits only the first count items. *skip, count, skips the first count items. *zip, observable 1, observable 2, by function, combines emissions from two observables using a function. *reduce, initial value, accumulator, applies an accumulator function to each item emitted, emitting only the final accumulated value. *scan, initial value, accumulator, applies an accumulator function to each item emitted, emitting each intermediate result. 7. Error handling. rxjava provides operators for handling errors. *on error return, function, emits a fallback value when an error occurs. *on error resume next, function, emits a new observable when an error occurs. *retry, count, retries the observable up to count times if an error occurs. *retry when, function, retries the observable based on a conditional logic provided by a function. 8. Schedulers in Android. *schedulers.io, used for I/O bound operations like network requests and database access. It uses a thread pool. *schedulers.computation, used for CPU-bound operations like calculations and sorting. It uses a thread pool optimized for computation. Android schedulers. Main thread, used to update the UI on the main thread. You must use this to modify UI elements. Example 9. Back pressure. Back pressure occurs when an observable emits items faster than the observer can consume them. This can lead to out-of-memory error exceptions. rxjava provides the flowable type to manage back pressure. Flowable provides strategies for handling back pressure. On back pressure buffer, buffers all items until the observer is ready. Suitable for cases where you can tolerate a delay and don't want to lose any data. Be careful, as the buffer can grow indefinitely. On back pressure drop, drops the most recent items if the observer is not ready. Suitable for cases where losing some data is acceptable, example sensor readings. On back pressure latest, keeps only the latest item, dropping all previous ones. On back pressure error, emits an error if back pressure occurs. 10. Integrating rxjava with Android components, code examples. Example 1, click handling with Rx binding, Kotlin. Example 2, network request with retrofit and rxjava, Kotlin. Example 3, search suggestions, Kotlin. 11. Best practices. Dispose of subscriptions. Always dispose of your subscriptions to prevent memory leaks. Use disposable or composite disposable to manage your subscriptions. This is critical in activities and fragments, especially in OnDestroy view. Use the correct schedulers. Choose the appropriate scheduler for your operations, I/O, computation, main thread. Handle errors gracefully. Implement error handling to prevent your app from crashing. Understand back pressure. Use flowable and appropriate back pressure strategies when dealing with large streams of data. Keep observables small and focused. Break down complex operations into smaller, more manageable observables. Test your rxjava code. Use tools like rxjava's test observer to thoroughly test your reactive code. Avoid blocking operations on the main thread. Never perform long-running operations on the main thread, even within an observe on Android schedulers. Main thread, block. Offload the work to a background thread. Don't reinvent the wheel. Leverage rxjava's built-in operators as much as possible. They are well tested and optimized. Be mindful of context. Avoid holding references to activity or fragment instances within your observable chains to prevent memory leaks. Use a weak reference if you absolutely need to access the context. Consider using lifecycle-aware components, example viewModel, to manage data and business logic. 12. Combining rxjava with Kotlin coroutines. Kotlin coroutines can integrate well with rxjava. You can use rxjava 3 Kotlin library to provide extension functions like toObservable to convert a coroutine's result into an observable. You can also use suspend cancelable coroutine to wrap an rxjava observable into a coroutine. 13. Conclusion. Reactive programming with rxjava can significantly improve the responsiveness, maintainability, and readability of your Android applications. By understanding the core concepts, operators, and best practices, you can effectively leverage rxjava to handle asynchronous operations, manage data streams, and build robust and scalable Android applications. Remember to dispose of subscriptions and handle errors properly to avoid memory leaks and crashes. As with any technology, practice is key to mastering rxjava. Start with simple examples and gradually build up to more complex scenarios.